Hi, in this video we are going to talk about why is it good to use generics at all. And first of all, because in software engineering, bugs and errors are simply a fact of life. We are not able to avoid them. But it's very important to see that some bugs are easier to detect than others. There are two main types of bugs: compile time bugs or compile time errors, and runtime bugs or runtime errors. Compile time bugs are very easy to detect. Compiler's error messages helps to figure out what the problem is, and we are able to fix it without starting the application itself. Runtime bugs, on the other hand, are much more problematic because don't always surface immediately, and it may be at a point in the program that is far from the actual cause of the problem. So basically, it's very important to see that runtime bugs are very hard to detect. It's very hard to debug runtime bugs. Often you have to use the Eclipse debugger, for example, in order to be able to detect that what is the problem. Compile time bugs, on the other hand, it's quite easy to detect because you are not able to run the application, and usually you got an error message that what's the problem. So this is why we like compile time bugs instead of runtime bugs. So why generics are important? What does generics has to do with all of this? Basically, generics add stability to your code by making more of your bugs detectable at compile time. So basically, with the help of generics, we are able to reduce runtime bugs to compile time bugs. Why do we like compile time bugs? Because they are easily detectable. We are able to detect it with the help of the compiler's error messages. We don't have to debug it. We don't have to think about the problem for hours. So that's why we like compile time bugs, and with the help of generics, we are able to reduce most of the problems to compile time bugs. Okay. Of course, generics are good for enabling types to be parameters, so we are able to create types such as classes or interfaces, and we can reuse the same code with different inputs. For example, we would like to create a draw method, and without generics, we have to specify as many draw methods as many objects we want to draw. If we want to draw a car, we have to specify a method that's going to wait for an input such as a car. If we would like to draw a bus, then we have to implement the public void draw method again, and we have to define the bus as a parameter. Of course, there is a much better solution. Basically, we have to use generics. We would like to create a draw method that's going to get a type or an interface as a parameter, and basically every type as a parameter. So we are able to draw a car, a bus, a bicycle, a motorbike, and whatsoever. So basically, we are able to reuse the same code with different inputs, and we don't have to define as many methods, as many functions as the number of objects we want to draw. So beside these type parameters, generics has many benefits over non-generic code. For example, stronger type checks at compile time. If the code violates type safety, then compiler will warn us, and fixing compile time errors are easier than runtime errors. This is what we like. We like compile time errors, and with the help of generics, we are able to avoid runtime bugs, and we are able to get to compile time bugs instead. It's very important we are able to eliminate casting. We are able to use lists like this. We don't specify that what items, what objects we would like to store. We just put strings, for example, and when we get the items out of the list, we have to cast it. And basically, it is a common programming concept that if you have to use some casting during the application implementation, it means that it is not the best solution possible, because we are able to use list in a generic manner. And if we specify that the list is going to store strings, then we don't have to cast the items when we get it from the list. So this is a better solution because we can avoid casting. And what's very important that we can implement generic algorithms, so we can reuse the code as we have discussed here in this section. Let's suppose the fact that we would like to implement a sorting algorithms, but of course that you may come to the conclusion that okay, sometimes we have to sort strings, sometimes we have to sort characters, sometimes we have to sort doubles or integers or floats, but basically the sorting operation is going to remain the same. I'm not sure whether you are familiar with bubble sort, merge sort, quick sort or heap sort, but of course the fundamental basics is going to be the same no matter what we are going to sort for strings, double, integers. So okay, the first solution is that we are going to define as many methods as the number of types we would like to sort. One method for doubles, one method for integers, one method for strings and characters, but basically it's not going to be very flexible because we have to repeat approximately the same code over and over again. So we just have to use generic parameters, and with the help of generics, we are able to sort strings, doubles or integers with the help of the same method. So basically that's all about the motivation behind generics and why is it good to use generics at all. Thanks for watching.